Hello and welcome to the video. This is a video back at 3DXR. Now, for those of you that have watched the channel for a long time, you'll know that 3DXR is one of those places that I love to visit. It's like a child going into a sweet shop. And Ben, who is the owner of 3DXR, has very generously given up some time again today to help me set up my transformer wing. Now, the transformer wing is something that we had a look at Christmas and I built out a couple of weeks ago, but it needs a flight controller. And the flight controller I've gone for in this particular case is a PixHawk. And while those of you watching this may think that I know a lot about PixHawk, my knowledge is a drop in the bucket compared to Ben's. Now, Ben's business here at 3DXR is really focusing on building and maintaining and creating custom vehicles for customers. And here are some images that I'll just show of the things that were cluttered around the workshop. And every time I come here, it always costs me money. In fact, I've just bought a load of stuff from 3DXR while I'm here, so you'll probably find a Radix build on the channel in the future. But Ben, thank you very much again for the time this morning, because it's great to have an expert putting the PixHawk in. And what I did while Ben was doing this, I've kind of shot lots of video and made a note of the steps that Ben has gone through to set up the PixHawk, because whereas I've set up probably a dozen PixHawks in my life, Ben's probably set up 10 times that amount. So Ben, thanks again. Could you just take us through and kind of give us an expert view? Because for those of you that have never seen a PixHawk setup before in a fixed wing, go and have a look at the mini Talon build that was done about 8-9 months ago. I'll put a link here in the description. But Ben has just gone and done it in a slightly different way, and it's been really fun to watch. So Ben, what do you kind of look at when somebody walks in the door like I did this morning with a big wing under their arm wanting to put PixHawk inside?
You arrived today with your transformer wing. So it had already flown in normal traditional RC mode. So you had the servos fitted, the motors fitted, and it was just a case of adopting it to PixHawk, the cube in this case. And I think you mentioned that you wanted to do a downward facing camera, potentially set it up for a sort of mapping wing. So yeah, so we've got plenty of space inside. Yeah, so in this case we chose to use a mini carrier board and a black cube, and that had plenty of space to get all the equipment in. The other bits of equipment we needed would be the GPS, telemetry radio, in this case to talk to a ground control software, to talk to Mission Planner in the air.
Great, and that's because the USB is normal. Where we're going to put it, the USB is going to be covered, so the telemetry radio will allow us to change settings and
change
calibrate
settings on the ground, yeah. But also during flight, you can see the progress of its automated mission.
Great.
We also would choose to use an airspeed sensor, so we go through the setup of that a bit later on. The airspeed sensor, when set up correctly, is extremely useful. It'll allow you to maintain a perfect speed, a cruise speed to carry out these missions, and it can also help if you choose to do automated landings.
I'm going to design and make a 3D printed mount for that, because at the moment it's kind of stuck out the front. I've not used an airspeed sensor, but I know one of the things you were talking about, and we'll cover this in a minute, is that a badly set up airspeed sensor is probably more dangerous than no airspeed sensor at all. And there's some tips and tricks, and we'll come on to that. So if I can very quickly go through the steps that you've done, if you can kind of shed any light. Again, the general process is the one that is in the documentation for RD Pilot, but the way you've done it seemed to make an awful lot more sense. So the second thing you like to do is set up the radio, and that looked like the standard 4 controls. Even though this is a flying wing, no mixing on the radio. Channel 8 was on a 3-position switch that allowed us to change modes, and channel 5 was set as a legacy thing. Again, images here for how my radio set up, but there wasn't really anything else that we had to do on that, was there?
For fixed wing, no. So a lot of the fixed wing, especially mapping drones, have interesting control surfaces. They could be V-tail, elevons, A-tails, have various assortments of flaps and air brakes. But yeah, just to remember that there's no mixing on the transmitter. You just have your normal 4 sticks, a mode switch. In this case we used a 3-position switch. I generally find that you do need more than 3 modes for fixed wing, so my usual setup would be to use 2 sticks to provide 6 flight modes. The switch you mentioned on channel 5, I normally set up a reset mission channel, which allows you to restart the mission from the beginning if something the light changed or something affected the mission you were doing. So I like to have the transmitter ready early on, ready to just bind, map it and calibrate.
Great, fantastic. So the next thing you did then was actually flash the firmware. So you plugged it in. Nothing was really attached to it at this point. It was just plugging it in, connecting to it, flashing the firmware. We did talk about some changes to the firmware this time though. You did attach the buzzer as part of this, but the firmware is changing, isn't it, for ArduPilot?
Yeah, so any new setup you do on your PixHawk or any ArduPilot vehicle, you'll be prompted with the option to use Shibios. Now, Shibios is a new real-time operating system that replaces NutX. The support for NutX will be dropped in future major releases, so we'd encourage people now to use Shibios.
Fantastic. Next job then was the GPS calibration. So you attached the GPS and you actually physically attached it to the top of the cube. And why was that all done outside of the plane?
Okay, so the next calibration step, the first actual calibration we want to do is the accelerometer calibration. What I did was I stuck the cube and the GPS together with the orientation facing the same way. And this is just to allow what can often be an easier calibration process out of the plane. So when you're doing the accelerometer calibration, you want to place the cube on each side and you want it to be nice and flat. So the manufactured case the cube is in is square with 90-degree sides. Trying to do this on a large plane can be challenging. So yes, some people will do all these calibration steps in the plane once it's finished. I like to do some of them earlier on. So we also, after the accelerometer calibration, we moved on to a compass calibration. Again, the final compass calibration will be done in the field and free of any magnetic interference, large metal objects.
Fab. And that's the usual compass dance. Now, in between all of that, you've also gone through the power setup and done a reboot. And most of the time, ArduPilot seem to be telling you when to do the reboots. But I noticed that for you, once you decided, because we're also using a power module here to power the device, you said you had to do a reboot in order then to configure it.
Yeah, a couple of times you'll be prompted to reboot. So after a compass calibration, it will tell you to reboot. Something like the battery monitor, this is what catches a lot of people out. They want to put the settings in, so you'll have some calibration data to enter for your battery monitor. And what you basically have to do is you have to reboot after selecting the monitor type. So in our case, it's the PowerBrick Mini that comes with these products. You do need to do a reboot for it to work and to enter the values.
Making sure that the radio was set to no pulses, and again, see my video on how to set up failsafe on the radio. For using S-Bus, no pulses is one of the safest ways to do it if you're using a flight controller. So you plugged all that together. In terms of power, you talked a little bit to me when we were putting this together about the use of BECs and the power from the electronic speed controllers. Can you just very, very quickly just talk about your thoughts on that? So
on the model you brought, where we've just got 2 servos, it's got 2 motors with your built-in BECs, that's sufficient for your use. The main thing to note is that the servo rail is not powered, so you have to provide the necessary power to that rail, and in this case it was in this case the power came from the BECs on the ESCs. If I'm running more servos or anything else connected to the servo rail, I will use dedicated BECs, maybe with a higher current rating. It might be 5 amps and somewhere between 5 and 6 volts depending on what you want to do.
So for the professional rigs that you're building, you're using opto speed controllers and a separate high amp UBEC to power everything?
Yes.
Okay.
Yeah.
All right, good tip. Then you plugged in the airspeed sensor into the I2C port, and then you tested the airspeed sensor by blowing into it, which was fantastic. And you can see here on the left, that's the actual airspeed sensor. Again, I'm going to mount this properly, and we'll come back to this model again.
So like we said earlier on about the airspeed sensor, some considerations. First of all, the mounting of the airspeed sensor. So you're set up with twin motors at the front. I would not put an airspeed sensor on a pitot tube behind those anywhere. So in the front, in clean air, in a location that's not going to get damaged on a sort of harder landing. So in this case, it's raised above the battery canopy in the custom housing you're going to make. Also, with the particular airspeed sensor we use, it will start to give readings straight away once you've plugged it in, but it will not be using airspeed in its flight. You need to enable it, but before you enable it, you need to calibrate it, which will involve loitering or flying around in a circle for about 5 minutes, in which case it will put the correct airspeed ratio in. So this is something that varies from sensor to sensor, and also in your configuration. Some people may have used longer tube or shorter tube, or there'll be different pitot tubes, so it's important that it's calibrated.
So I think what we're probably talking about doing, Ben, is me to come back up another day in the hopefully not too distant future, and we'll actually maiden this and show how to do that. But it is something that I don't think a lot of people realise, that there's an extra couple of steps if you're going to put an airspeed sensor on it. But an airspeed sensor is really good, and I'm interested in it for this because it'll also help with making sure that it doesn't drop below stall speed and things on approach and landing, and any kind of mapping or filming that we do with this. It'll do a much better job of maintaining speed. Then we calibrated the radio. Then you actually set the flight modes. So the flight modes can be anything. We just use a 3-position switch here, nothing particularly fancy. Yeah. What's your recommendation for flight modes going to take it out for the first time?
First time, depends how adventurous you are. And it depends on the size of the plane as well. So this plane here, you could just go off in manual. You could go off and fly by way array, which is a stabilized mode. I have a slight feeling, we don't know yet, but maybe the default settings need to be reduced a little bit, the default PIDs for this particular wing. If I'm using a very big plane, I sometimes put in a takeoff command and launch it as a mission. If it's a known big plane where I'm duplicating the setups, then that might be its first flight, and I'll be on the switch ready to flick it into manual if I need to change over. The normal flight modes I put on planes: fly-by-wire A, sometimes the B version, which holds the height. I will have the auto mode, because most of the work is flying grids. A loiter mode, so just the ability to put it into a circle. So this might be a requirement that you have to be able to hold in a position to avoid a collision. A return to launch, and my own personal ones I might retain manual, but for customers, don't let them have a manual control.
At the moment, we've just plumped for 3. I'm probably going to set up some mixes. I also have the rotary control on mine, so I might do that as well. Yeah. You were saying that there are potentially changes to the code coming, so launch mode and return to home mode will be selectable on switches too, which I think would be a good idea.
One of the beauties about the Ardu plane in this case, and using PixHawks, is how easy it is to use so many different wing plane configurations, even VTOLs, quad planes now. So, like I said previously, we did no mixing at all on the transmitter, but when we'd calibrated the transmitter and we'd done some of the initial steps of calibration to get rid of all our warning messages, we went in and told it what is plugged into where. So in this particular one, we had left motor, left elevon, right elevon, and we used ports 1 to 4, and we basically just defined that number 1 is the left elevon in this case, 2 is going to be the left motor, and so on. On other configurations, you might have flaps, and it's as simple as setting the servo output to a function and maybe adjusting the minimum and maximum PWM values if you need a bit more in that sense. But yes, you're just, if you want to change a plug, you can just change that value. Very, very powerful, very easy to swap functions.
It's the most powerful custom mixer I've seen. Is that something that was introduced recently? Because in the setups I've done, I can't remember having to do that. Yeah,
it's been out for probably over a year now in its particular form. Previously, you would have had to have said this has elevons, set that to yes, and then there was a complex reversing procedure if they weren't working by default. So that was the older 3.7 plane. We're on 3.96 now, and there's gonna just about to be a big update. But yeah, that's setting what each control surface is very, very easy now.
Part of that, and again at this point we haven't installed anything inside the plane, you're just building a bigger and bigger mass of wires and bits connected. You did put the camera trigger together, you were using a Sony RX0 with a little trigger, and you kind of plugged that all together and we tested it. Also plugged in the telemetry radios and did all those pieces. And one of the things that I was quite interested in is that you tested the entire setup you ran it from an external battery with a battery eliminator circuit. You kind of plugged in a main flight battery to make sure you could see the voltage. You did all of that before you even reached for the hot glue and the double-sided foam tape to put it in the plane. And is that something you always do?
It was a bit of a spaghetti mess. There's certain steps I always want to do before it goes into a plane. So I'll always try and do accelerometer calibration using the cube surfaces. It makes it easy. If it's redone again later, fair enough. I normally want to test equipment works, check the GPS. Maybe I'll flash the firmware outside of the plane. The big planes, which you might have shown some pictures on, they're actually the flight stack, if you like, is all built outside the plane, and then it's glued in the center. So it's a 2-deck system of carbon fiber where I'll custom make all the cables and make everything fit really nicely. So in that case, yes, that all gets tested because it's about to get encased in a plane.
So I know it's bugged you with a couple of things on mine, things like the power cables that I will fix before I come back. The ones that you do for customers compared to the job that you've very kindly done for me today is a very different proposition.
It's one of those. I mean, when people are using them commercially as a tool, you have to think about, can this person pull this wire out by mistake? How much of it can you sort of hide away to stop someone making a mistake? The customers that get these don't know that Servo 7 is a V-tail output, and if a cable comes out, it's not going to get put back in the right place. So it's trying to take that approach with it to keep it clean and tidy and safe.
Fantastic. So at this point, you tested the radio, you tested the airspeed, GPS, made sure it was moving in the right way, did everything that you could, and then literally the last thing you did was then start installing it in the plane. And you put the GPS on the back in dorsally. I'll probably do, and again, you wanted to put a little bit more time into it. I've just used a double bit of foam. The PixHawk, reasonably close to the centre of gravity in the centre.
Yeah, if where possible, put it as close to the centre of gravity. You can dial in those settings if it's offset. Only on really big stuff would you need to do that. The main concern on this one, which you didn't actually pick up till the end, is there's a lot of magnets being used to hold it together. Now, magnets and compasses don't mix very well in other builds, so I modified a powered disco. The magnets had to be taken out. Also, the nanotalons, I had to take the magnets out of that. So yeah, making sure it's accessible. One thing I would probably do to this is make a little hole to be able to get a USB cable in the side of the cube for updating, because you can't update the firmware over a telemetry radio at the moment. It's always good to have that access, and if it is a plane that's going to be used for mapping, you'll want to pull the logs off it quickly. Sometimes it's a bit slow with the radio. If you're able to put a USB cable in, then that works. You can do extensions.
I think I might end up popping a little extension on it, because this is less the kind of model that you would normally make, which is for kind of professional pilots and those kind of uses. This is kind of more of a hobby grade thing, but
multi-purpose.
Well, a bit of fun. I know I always keep joking about the FPV stuff, but it'll definitely end up in that. And once the physical install was done, it was really just a case of making sure that everything was connected, because you were connecting the servos up, make sure they was in the right outputs. Obviously, before we connected power, we removed the props for safety, and the last thing you did was just making sure the control surfaces were moving in the right direction and nothing needed to be reversed. And again, that looked different to me than what I was used to. That's obviously changed as part of the servo mixing output stuff.
Is that, you mean the pitch being reversed on it, right? Yeah, so that's a common thing that catches people out when you're in the radio calibration page. All the sticks move normal. When you come to the pitch and you raise the pitch lever, the bar on the screen will lower, and vice versa. Yeah, that often confuses people. And
I also had one of my elevons was reversed as well. So, left elevon, I think it was.
So the first step, once we had everything fitted and we're testing these controls, we were in manual mode, and what we want to do is make sure that a movement on a transmitter is correct on the plane. And in your case, yes, we had a elevon was reversed, so we went to the servo output screen, found out it was the left
I think
elevon,
it was the left.
And we pressed the button that says reverse, and magically
all done.
Was done.
A lot simpler than it used to be.
So it was responding correctly to the transmitter, And then the next thing we did was put it into a stabilizing mode. So we used fly-by-wire array, and we wanted to move the plane left and right and forwards and backwards, and we were making sure it was countering your movement in order to stabilize itself, which was all correct.
Great, which means that it went in okay. So the last little thing that you noticed, and you've seen this on a couple of times, is we couldn't arm it initially, and that was because there was an error talking about the trims for channels 15 and 16. Just in case anyone else sees that, what was the fix for that?
That seems to crop up every now and again. It's put in the calibration values for the radio. We're not using all 16 channels. The default trim in this case was set below the minimum output, so it told us exactly what we needed to fix. It said RC16 trim is lower than minimum. Yeah. So when we went into the parameters list and typed in RC16, we found the trim number was low, and in this case, the first time it happened to me, I had to look for it, find it, change the number, and
you just set it to 1500, I think, was it?
Just set it to the middle value. Yeah, it's just a little bug that's happened where it's it hasn't put 1500 in the channels we're not using. And other things as well, when you are going through this setup process, one of the reasons I like to do this, a lot of calibration outside of the vehicle, is that it gets rid of the messages. If you first flash a PixHawk, it's going to say compasses aren't consistent, no GPS, radio not calibrated. If you go through the list and get rid of those, hopefully you'll find any genuine things that need to be done that haven't been set up correctly.
And also, if you do that before you put it in the plane, and then you put it in the plane and then find that something isn't working, it's probably something you've done.
Yeah.
And so you have an idea where you've got to look, I guess. Is that right?
So all these things are called the pre-arming checks. So if you try to arm it and it doesn't let you, it's there for a reason to protect you. If it is saying compass is inconsistent, you normally find that the user has fitted the compass backwards after they've calibrated, or they've done something silly, and hopefully it picks up these and stops something dangerous happening. It would do that for low battery as well. If you set the battery fail-safes, it won't let you take off if you've got a low battery, which is helpful.
Good
things.
Idea.
Yeah.
So thank you for that. So I hopefully then we'll come back and we'll actually complete this. We'll give it a test flight. We'll calibrate the air sensor. What we'll also have a go at is seeing whether or not the compass is happy with those magnets in the wing. Because if we do find that there are issues with the logs, then we can pop those magnets off and we'll use use some glue to put them on instead. But I thank you very much again for your time today and going through that. It was very fun watching someone else go through a PixHawk setup, and I've learned stuff today. So thanks again for your time.
No problem.
Thanks for watching the video and watching right to the very end. You can find me in all the usual places on social media, and if you like the video and like what I'm doing here, then hit the subscribe button and hit the bell notification icon too. If you really like what I'm doing, you can go the extra mile and become one of my Patreons for access to me directly for support, and also giveaways and regular updates too. If you're looking for particular content, then check out the playlist. I organise all of my videos into playlists, so if you're looking for a particular topic, you can find everything here. If it's called Introduction To, it's designed to start very simply and build on that simple introduction to teach you all about it. If it's called For Beginners, then that is really aimed at people who are brand new to that part of the hobby. You can also search on YouTube for anything that you're interested in using the search function at the top. So iNav Painless 360 will find all of my videos and even the playlists around iNav. So thanks again for watching and happy flying.